I'm Ron Thompson, and I'm an astronomer with Southern Maine Astronomers. And I've been part of the program since February of 2012. Cindy and company came to one of our club meetings with the primary who was instrumental in getting New Hampshire started with the library telescope program. And he mentored us and gave us the what ifs and wherefores on how to modify the telescopes to make them very user-friendly, if you will. And I jumped on the bandwagon. I thought this was a great thing, and I've been here since. Done a lot of workshops. Some of you I've seen before, and some of you I haven't. You have two scopes, Blue Hill, and we had fun. I used the exercise with the kids that we did in the dark.
Oh, yeah.
Turn the lights on. Yeah, I'll talk about that again later. But yeah, that was fun. That was really an eye-opener, if you will. Especially when you turn the lights back on. The telescope really is very user-friendly, and short of throwing it in front of a Mack truck, it's almost indestructible. I dropped one on the floor, that's how I know. I did break one of the feet, I had to fix that. But in the meantime, I thought, boy, I wonder what that did to the optics. And you know what? It didn't do anything to the optics because of the modification. It was still spot on, nice sharp focus, everything was primary, right on. So that was a good lesson for me too, in that, yeah, I did drop one. It wasn't a bad thing necessarily, because I found out that the modifications make it bomb-proof. What I'd like to do too is just impress upon you that some libraries, like your library in Blue Hill, might even want a second telescope. The reason for that is waiting lists, as Cindy said, in some libraries are anywhere from 16 to 26 weeks. You know, it's crazy.
We first reserve on ours for next summer already.
Till next summer.
Not until, but
yeah,
at least
but
one for next summer.
Unbelievable. And that's really the way the program's been going in some of the other places as well. And unfortunately, there are some places that have the telescope, but it's not being used. And your example, you've got two of them, and they're nowhere in sight. You know,
bring them today
they're
for
all
maintenance because they were out.
Yeah. If you think they need some maintenance too, that's good that you brought that up. You can call Cornerstones and ask Cindy to send the trunk around to load your telescope in and bring it back to the office. You know, the truck that goes around and deliver books and such. I don't know what you call that.
Van delivery.
The van delivery, yeah. So if your telescope needs a tweak or two, all you got to do is call Cindy. She'll send the trunk. There is a sheet of paper in there that explains how to pack it, and it's very easy. Just drop it in, basically. It's all foam lined. And she'll call me and say, hey, Ron, we got one that needs to be tweaked. I'll come in, tweak it, put it back in the trunk, and send it out. It's that easy. So don't be afraid. Let's get started on the program. What I'd like to do, now some of you have probably seen these. How many of you have seen these before? A couple of hands, yeah, 3, 4, 5, 6, 7. Sky maps, right? Why do you want a sky map?
So you know what you're looking at.
Yeah, without a sky map, you're lost. What I'm going to do is I'm going to pass these around. So have one and pass it on. If there's any extras, just leave them on the table. What I like to suggest is, and those of you that have used these know pretty much what I'm going to say, go to skymaps.com, www.skymaps.com. It's free. Every month the sky changes such that you should have a new one. Now your patrons can use these just as they are, because all you need are your two eyes, really, and a chart. Without a chart, two eyes, well, you can look at the sky, but you know what you're looking at. The chart gives you a, I don't know, I guess probably the eyes to the sky. And then you can use your eyes along with those eyes to show you wherever you're facing. If you face north, you're going to find the Big Dipper. So you'd rotate your paper so that north is at the bottom. Put your thumb on north. That's the best way to do it. Put your thumb on north. And face north. You know where north is? Everybody know where north is? How to find the Big Dipper? If you don't know where north is, get a compass out. Compass will show you where north is. Then you can find the Big Dipper. The Big Dipper is a circumpolar constellation. It's around the North Pole, North Celestial Pole, constantly. And in our hemisphere, we can see it year-round. So consequently, if you go out at night with this thing, with your thumb on north, you can find north, there it is, and find the Big Dipper. That gets you started. From there, you can turn the paper around so that east is, you got your thumb on east. Now everything seems to come up in the east, doesn't it, right? Where does the sun come up in the morning? Comes up in the east and sets in the west, right? I'm going to turn my back to you for just a second. I'm going to face south. And I'm going to make a little square with my thumb and forefinger. And I'm going to hold it about 43 degrees. That's because we're at 43 degrees latitude, right? Okay. So when the sun comes up on the horizon north, this is north, and this is going to be west. North is at 43 degrees. As it comes up at noon, high noon, north is going to be straight up, and because it's pointing west, and it's going to set in the west. It's set at 43 degrees. Now, does it really do that? Does the sun really do that?
No.
No. Thank goodness. I don't want to have to go that route. It appears to do that, though, and that's what we call apparent motion. Now, the planets do the same thing. They're across the ecliptic plane, and you can see the dotted line on the chart. That dotted line is called the ecliptic. And you're going to, except for Pluto, you're going to find most of the planets as they come along and are visible. There aren't any visible planets right now, unfortunately. But anyway, they'll be along this ecliptic when they are visible. And they'll show on that particular chart. Yes, you can go from year to year. December's chart looks just like that as far as stars and constellations go. But the planets are in different locations. So you want a fresh one every month, basically. So the 1st of January, you can go on to skymaps.com and print out a brand new chart.
So we should be doing that to accompany our telescopes as they go out?
Absolutely. I recommend it highly. Even if your telescope is checked out and somebody says, gee, I'd like to check the telescope out sometime, hand them a chart. Say, get familiar with the night sky. One of the things I stress is these two things are most important. These are your eyes to the sky. That's your eyes to the sky too, because that tells you what's up and when and where these different sky objects are. These two eyes give you a expanse of sky that you can enjoy. You can see shooting stars, if you want to call them that, meteors, meteorites, meteor showers, satellites flying by all the time. It's incredible what you see out there. And just have the kids lay out on a lawn chair, and if they have to, get in a sleeping bag and just look up at the sky. You know, and watch all the stuff going on. It's really amazing.
The space station.
Hmm?
That's fun to see the space station.
Yeah,
Yep.
yeah. And you can go heavensabove.com and find out when these different satellites are coming over too.
Do you have preferred apps that people can use for?
Sky Maps Pro. Sky Map Pro. And Skywalk is another good one. Skywalk.
right here.
And any of those are fine. Some of them are a little more expensive than others. The one that I have is I forget how much I paid for it, but it was a step above. I'm able to, if I have the controls for it, I can control my telescope with it. And there's all kinds of different apps. There's apps just for planets, and some of those are free. Yep, there's an app for that. Now, we talked about the front side of this. Let's turn it over and look on the back side. That's important too, because it shows you what you can see in a dark sky area with the naked eye. It's amazing what you can see with your naked eye. If you have binoculars, that's the next step. Once you're familiar enough with the night sky, then you can grab a pair of binoculars and you can look at some of those deep sky fuzzies a little bit closer. But you got to remember this. When you go to binoculars, what are you doing? You're decreasing your field of view. Now, if you want to go find the Andromeda Galaxy and you're not familiar with the night sky, how are you going to find it with a pair of binoculars if you can't find it with your eyes? So you got to get familiar with the charts using your eyes. Get familiar with the night sky. What's it like using a telescope? What do you think? looking through a straw?
Yeah.
You can't find it with binoculars. How the heck are you going to find it with a straw? And that's what it's like using a telescope. It's like trying to find something with a straw. Consequently, a lot of people end up with the telescopes that they give the kids for Christmas, and it ends up being an orphan in a closet for the rest of its life. And that's unfortunate. So I don't recommend people just go out and buy a telescope for the sake of it. You might look at the moon, but that gets old after a short while. Any questions on the sky map? Very important piece of material to have. Yes?
I think we bought a plastic one to go with the telescope. Is that
Oh,
not
Planisphere?
as good as this?
The Planisphere?
The flat plastic one that spins.
Yeah, the Planisphere.
Okay.
Yeah, no, that's fantastic. That's a whole year's worth
Okay.
of sky maps. Yeah, matter of fact, if you have the Binoculars and Planisphere from Cornerstones, some libraries have opted to do that. So when the telescope is gone, they can check out the Planisphere and the Binoculars. And they're inexpensive if you want to do that. You just call Cindy and say, hey, I'd like a package of binocular Planisphere. That's great. But I'd still encourage them, because then they can to have a sky map, because they can take it home and write on it and do some good stuff with it. And then of course you have what you need a telescope to use to see some of the real deep sky objects. So that's a very handy piece. What I want to do now is pass out some strips of paper. We're going to get going with our Planisphere, our solar system on a roll. There might be a couple there. Yeah, that's all right.
I like it.
Don't put any creases in it yet. See, there's a few there, so take one and pass them. Have one and pass them if there's enough. Okay, solar system in a roll. This is typically how you look at our solar system in any kind of a picture in a magazine, whatever. You can see the inner planets, the rock planets, we're the third rock from the sun, the inner planets, and then of course we have the asteroid belt beyond Mars and between Mars and Jupiter, and then Jupiter and the other gas giants, and poor little Pluto, he's off on his own. Those planets follow the plane of the ecliptic for the most part, as I said before, except for Pluto. Pluto does use Neptune's orbit somewhat, and then he goes out into the Kuiper belt, so it's quite a loop for him. There's a chart here that shows the planets and their average distance from the sun, because remember, not everybody's in a perfect circular orbit. They're sort of slightly ecliptic, not much, but a little bit. And that's because of the interaction of the magnetic fields from all the other planets and the sun tugging on them. Okay, what I want to do is have you take a pencil that's on the table there and write the sun at one end. And if you draw this thing down to the bottom, write Pluto / Kuiper belt, K-U-I-P-E-R, belt. So at the top you've got the sun, and at the bottom you've got Pluto and the Kuiper belt. All right, now we're going to put a crease in it. Put the sun and Pluto together, fold it in half, make a nice tight crease right across the middle. Who has an idea what that planet is right there at the crease? Halfway between the sun and Pluto.
Saturn?
Saturn, Jupiter,
Mars?
Mars. Halfway between Pluto and let me give you a little clue. I'm going to keep this at arm's length. I'm going to turn my back to you. What body part is that close to?
Okay.
It's pronounced Uranus.
Uranus.
All right? Uranus. So I want you to write on that first crease Uranus. That's the planet between the sun and Pluto, halfway between. Wow, that's incredible, isn't it? All right, everybody got that written down in that crease? When you do, fold it in half again. All right, now take the two ends and fold them in half again, which would be quarters now. So you get nice quarters here. And with the sun up and Pluto down, what's the planet between Uranus and Pluto? That ought to be easy. Yeah, Neptune. All right, going in the other direction now from Uranus toward the Sun, what is the top crease, do you think?
What's left?
So how many are left? Saturn, Venus.
Jupiter or Saturn? If it's not Jupiter, it's got to be Saturn. Okay, let's look at this picture before we go any further. The four rock planets are Mercury, Venus, Earth, and Mars. Following that are the gas giants, Jupiter, Saturn, Uranus, and Neptune. And of course Pluto. Pluto's a dwarf planet. Yeah, poor thing, he got sequestered. Anyway, he, like I say, he roams around Neptune's orbit as well as the Kuiper Belt. So write Saturn on this top fold. That's where Saturn goes. Wow, we've only got 3 planets and Pluto in all this distance so far? That's incredible, isn't it? Kind of makes you wonder why they call it space. All right, this is going to be a little easier. We're going to take the Sun and fold it down to Saturn now. All right, what planet is halfway between the Sun and Saturn? Jupiter. The gas giant Jupiter. Holy mackerel. We still haven't got to the rocks yet. Jupiter. Oh, they're primarily a gas ball.
You can really land on it.
No, you right down to the core. Yeah, it's gas. Yeah, mostly gas. Matter of fact, Jupiter at one time, had it kept on generating enough pressure in the core, may have ignited and become a star, but it never did. So it's a planet. Okay, come on, moving along. Now we're going to take the Sun and fold it down to Jupiter. Very carefully, nice and square. Make a nice crease. Okay, folks, what do you think is between the Sun and Jupiter? Ha-ha! The asteroid belt. Now the picture that I had before didn't show it, but it did show it in the first picture, didn't it? Remember, it showed the cone of the 4 rock planets, asteroid belt, then Jupiter and the gas giants. Okay? Now things are going to get a little tight because we're going to fold it down to the asteroid belt. Make a nice tight crease. Now, this is going to be what? The top crease now is going to be what? Mars, absolutely. All right, here's probably the most difficult part. We're going to do some folds again, and I'll walk you through it carefully. But the last 3 planets are going to have to be written somewhere on here. And I'm going to have you do this. Fold the Sun down to Mars. Now don't open it up. Fold it in half again. And when you open it up, the Sun should be at the top. And you got 3 creases, or actually 4. So Mars is going to be on there, followed by Earth, followed by Venus, followed by Mercury and the Sun. And you can write them in and just abbreviate it and give you a little extra room if you like it shows in the picture. This is a great project for the kids. How many of you work with kids? Oh, great, fantastic. You'll have a blast with this. This is register tape, 2-inch register tape. You can buy them in rolls of 3 at Staples. And just cut a 4-foot length. That's what these are, just about 4 feet. You know, it really gives a good representation, and especially when you get to the last folds, because they are small, it doesn't matter, you know, how long it is. Those last 4 folds are going to be small. They're going to be close together. You make it 5 feet if you want. It's still going to be half, quartered, eighths, 16ths, and right up to the nitty gritty here. Everybody got theirs labeled? So you might wonder now, why they call it space. Well, let me impress you one little more, a little bit more on space. The nearest star to us is Alpha Centauri, which is just like our star. It's a G2 star. It's 4.2 light years away, which means you'd have to travel at the speed of light for 4.2 years to get to it. Okay, we know that won't happen anytime soon. But on this scale, do you know where Alpha Centauri would be?
Portland.
Well, not quite that far. 6 miles.
Wow.
From our sun, Alpha Centauri would be 6 miles away. And now you know why we call it space. Because there's a lot of it. And that's the closest star to our solar system. Any questions at all on space? Grab your chart again. And I'm going to have you roll it instead of fold it, because when you unroll it, you won't have any additional creases in it. What I'd like you to do is, next to where you've got Mercury, put a 0.4 next to Mercury. On Venus, put a 0.7. Earth, you're going to put a 1. I'm going to stop right there for a minute. What do you think these numbers represent?
Compared to the size of Earth.
Mass.
No, distance from the sun. Okay? We use the astronomical unit instead of average distance in miles or kilometers. It's easier to say. So instead of saying the Earth is 93 million miles away, we say it's 1 astronomical unit. That's the measure for the rest of the space, if you will. All right? So because Mercury and Venus are closer to the sun than Earth, they're less than 1. Now as we go out from there, from Earth, Mars is 1.5. The asteroid belt is 2.6, excuse me, 2.6. And then Jupiter is 5.2. Saturn is 9.5. Uranus is 19 astronomical units. Neptune is 30. Pluto averages between 30 and 50. Remember I said he was a wanderer? Yep. He goes into Neptune's orbit and all the way out on his 248-year circle around the sun through the Kuiper Belt. Chances are when he goes back through the Kuiper Belt this time, he may lose one of his 5 moons. Or, he may get just bounced out. Hard to say what he's going to hit when he gets out in the asteroid belt or what hits him. Never know. So AU stands for astronomical unit, and in relation to AU and the speed of light and distances, how long does it take for a photon to leave the sun and hit your face and feel the warmth on your face? How long do you think it, at the speed of light now? How many? 8 minutes. 8.33 to be exact. So as close as we are to the sun, it takes 8.33 minutes at the speed of light for that warm sun to reach our face. So what we feel left there 8.33 minutes ago. Now, when you're looking through a telescope at Neptune, which is 30 astronomical units away, or 3,670,000,000 miles, that's a mouthful, I'd rather say 30 AU, the light that we see from from Neptune left there, guess how long ago? 4 hours and 15 minutes. So the light that we see from Neptune left there 4 hours and 15 minutes ago. Now the Andromeda Galaxy is a beautiful galaxy. It's visible in the night sky right now. In a dark sky you can see that smudge, if you will. It's in the constellation Andromeda. 2.5 million light years away. So when you look at that in a telescope, the light that you see that outlines the Andromeda galaxy left there 2,500,000 years ago. That's old light. So you talk about space. Yeah. And you can see Andromeda really nice in binoculars. Yeah, because it's so big, it takes up a big area of the sky. And New Horizons is approaching Pluto. They just woke it up on its journey since January 2006. So it's going to head out to Pluto. It's going to take some spectroscopy to figure out what it's made up of. It's going to take beautiful pictures of it and send it back. Even Hubble is not good enough to resolve what Pluto is and its moons. So we had to send the spacecraft out there to do it. That thing traveled, what, 6 billion miles? 6 billion miles. It's in our own solar system.
Still on a warranty?
Yeah. Well, that's why they shut it down, so they would save the electrical circuitry in it from being operational all the time. They just kept on the necessary pieces of it to keep it warm, if you will, so that the things wouldn't freeze. And now that they've fired it up, it's going to start performing. And it'll be there, what, in July of next year, 2015. Should be really interesting.
So we'll be sending images before it gets there?
Yes, it's probably doing that right now.
And
Yeah, pretty awesome to think about it, you know. Never mind putting a little fillet lander on an asteroid. I mean, that in itself is amazing that the Europeans were able to do that. So, a lot going on in astronomy. And if you just want to enjoy the night sky, get a lawn chair and flatten it out, slip on a sleeping bag and just look up at the sky. Grab your chart for just a second. We've got a couple minutes left. Find the Gemini Twins. I'm not going to tell you where it is. I'm going to let you find it yourself. Where are the Gemini Twins? So if you hold the chart east, the Gemini Twins are coming up, aren't they? They're coming up in the east. So if you took your chart and held it and faced east, if you know how to find north, you can find east. And if you don't know where north is for sure, you can use a compass. They work at night too. Okay. You can just swing around to east from north. If that's north, this has got to be east. So you look up and you could say, okay, the Gemini Twins are coming up right there. Can you see on the diagram where it shows Geminids emanating from a point? Yep. So if you look east and you find the twins, that's where the Geminids will be coming from. Meteors, meteor shower. Yep.
Yep.
You may get 40 to 60 an hour if it's a clear night. Thank goodness right now the moon is waxing, so it's diminishing. It's not a great big bright ball that ruins your night vision. Oh, I was going to say something about night vision. How many minutes do you think it takes for your eyes to acclimate to the dark? Good guess. He said 20 minutes. Yeah, average is around 15, 20 minutes. Individuals are different. Some will acclimate sooner than others. In setting up your telescope, you want to set it up in the daytime. Why do you want to set it up in the daytime? Temperature. Temperature, yes. If you take it from a warm house to a cold environment, that glass, that thick piece of primary cell that's in the cell back there, has to acclimate to the outside air temperature. Think about summertime looking across a road. What do you see coming up off the road? Heat waves. A warm mirror through that skinny tube will generate heat waves as it dissipates the heat, and you won't be able to focus very well on it. So set it up in the daylight, and then go in, eat supper, whatever, watch the news, and then when it's dark enough, go ahead out. Give yourself 15, 20 minutes for your eyes to acclimate. Don't use white lights. From that point on, you want to use red lights. If you've got a regular flashlight, use 4 layers of red cellophane and just tape it on or rubber band it on your flashlight to give you a red light. Then you can read your chart, and you won't affect your night vision at all. If you need to go back in the house to get a drink, guess what? It's going to blow your night vision all to heck. When you come back out, it's going to take you another 15, 20 minutes. So, with that, unless you've got any other questions, I'm just about set here.
Cool.
Thank you.
Thank you.
Oh, you're welcome.